This one's for all the nerds out there. I've been playing around with the Immersive Portals mod once again because, let's face it, it's the best modification in the world. And I've come up with something that I've always wanted to be able to do in Minecraft. So I've created a 1x1 portal right here, which is scaling down this 16x16 portal. So this is actually a portal. This is a portal. You can see, look, I'm there. It's a functional portal. That would have been painful, I think. But the really cool thing about these portals is I can actually use the things on the other side of the portal. Look, I'm clicking on these tiny little buttons. So what I wanted to do is turn this little 1x1 area into a pin code. So we enter our pin number into this little button display panel here. The numbers will pop up on the screen, and when the numbers are correct, this little door will open. And to be frankly honest, I still have absolutely no idea how I'm going to do this, so this should be interesting. First things first, the number displays. I need to make it so that we can have various different numbers being displayed onto these things right here. And yeah, I think I have a good idea. And now that I'm placing in the wiring, I'm starting to realize that this could be a little bit more complicated than I was expecting. So what we're essentially creating here is a 7-segment display. So you've got one segment here, one segment there, one segment there. That's 3 segments. And then you've got the 4 segments in these areas here. And using a combination of these segments, we can create any number that we want using this display. If you imagine any form of digital display or calculator, they tend to have 7-segment displays to display their numbers. So at the back here, I've created 7 redstone lines that correspond to the 7 different segments. And all we have to do to display the numbers is power the correct segments. 30 minutes of head scratching later, I've realised that this method here is completely impossible. But something like this has much higher likelihood of working, because now I can actually power the 3 inner lines as well as the 4 outer lines as well, independently, making use of redstone torches. With the original setup, that wasn't going to work. Now the next problem that I'm going to run into is these systems are going to be directly next to one another. There's not going to be any space in between them, so I need to make sure that I build them so that they don't connect to one another, ruining each other. I did warn you this video was for nerds, so when we have these things next to each other, thanks to these blocks, these 2 lines won't connect, and thanks to these blocks, these 2 lines won't connect, so that should be everything all sorted. Now I just need to connect the redstone lines up into the 7-segment display, which shouldn't be too difficult. And now I just need to code in all of the numbers, and this is done by blanking out parts of the redstone, which will shut off the line, which gives us our number. So for example, to create a 6, all I have to do is blank out that redstone line right there, and there is our 6. And to create a 7, I just have to blank out the bottom ones, the 2 right ones, and then the middle one, and that should do it. And each column corresponds to a different number. I have no clue if I'm explaining this at all. But to the 7 people who are still left watching, I hope that you're enjoying yourselves, because I know I certainly am. I mean, come on now, how cool does this look? How cool does this look? I absolutely love redstone contraptions that look like they have no space inside of them. So at the minute we are displaying number 375, but if I pop down to the bottom here and start flicking these levers, we can go to 371. I can change the 7. I can change that to something else. Let's chuck that to, what's that? 351. All of them are working independently of one another. All of them can receive inputs. This is already a pretty cool redstone contraption. But now I need to hook these things up into this little button panel down at the bottom here. And I have now realized this is the least secure pin number in the world, because the pin number is displayed to anyone who is in the room with you. But still, you know, it's cool. Oh yeah, I got so caught up in the building of the redstone contraption, I forgot that I'd be able to see it on this little panel. This is the best thing ever. This is the best thing ever. Right. Button panel. How on earth are we going to do a button panel? So, I think the obvious choice here, and it might not be so obvious to build, is to make a red coder. So that means that each one of these buttons right here will have a different redstone signal strength attached to it that we can then run into a decoder, which, now that I'm looking at it, is going to be really... Oh... we really don't have much space here. This is going to be tight. I don't actually know if we're going to be able to do this, you know. A decent amount of head scratching later, I decided I wouldn't do a regular button panel because that would be complicated. So instead I'm doing this type of button panel, which is still going to be complicated, but not quite as complicated. And now I'm going to try my best to explain it, which is going to make it sound really complicated. So this is our button selector panel. It goes from 1 through to 9 and then 0. 0 is at the end right here. Currently I have number 1 powered, which means that these should be outputting a signal strength of 1. number 1 corresponds to a signal strength of 1. So when we have a signal strength of 1 being outputted because number 1 is selected on the button selector panel, then that will power number 1 on our little number displays, which as you can see is working perfectly. If we would select number 4 on the button selector panel, then we would get a signal strength of 4 being outputted, which would then select the 4th module of our 7 segment display, which would then display a 4 on the screen. Now all this green circuitry is doing is making sure that all of these signal strengths match up correctly, because if these weren't here, then they would all have different signal strengths, and different numbers on the selector panels would correspond to different numbers on the displays. I think that made sense. It probably didn't, but I feel like it did, so let's move on. The next piece of the puzzle is to create a red coder, because when you're dealing with signal strength, obviously up to the point where it's not powered, all of the other outputs are powered, and that isn't particularly useful. We want to get a singular output. So we're going to go from this to this. That is a lot more useful. And I think we can all agree that now that we have all of them in place, it looks incredibly cool. I mean, look at this thing as a redstone contraption. It looks like a little computer. So next up, as I begin to make my way through the redstone dictionary, we're going to be building an RS Snorlax latch array. That is going to be converting the pulses from the button presses into consistent signals? What are they called? Solid signals? Signals that stick around forever. Persistent. Let's go with persistent. Now, an RS Snorlax latch array really does sound complicated, but in reality is really quite simple. If you've ever built a button selector panel before where you only want one output at any given time, you will have constructed one. And if you've never built something like that, then you definitely should give it a whirl, because it's a really fun redstone project to work on. Oh my goodness. I am the luckiest person on planet Earth. This has all come together absolutely perfectly. Like, it fits in perfectly. This first one should actually be working now. Let's see. Does it actually function? I'm kind of nervous. That definitely wasn't an 8, was it? It made a noise. It made a noise as if it should be working, but it's not working. And that is simply because I've changed the side where I'm running the input from, so I just need to flip all of these repeaters around, which should now be done, and we should be getting something through the display. It's still 8. Was the last one that I pressed an 8? No. This is flipped. This is a different way round to what I expected. We need to have all of the redstone torches on apart from the one that we want selected. And that is going to be really difficult to do with the amount of space that we have. No! No! I will not be defeated here. I might be defeated here. This is ridiculous. I'm going invisible. I'm fading out of the video. After enormous physical pain, I came up with this solution and it didn't work. But after significantly more pain and frustration and gradually fading out of existence, I came up with this system right here. Making use of observers and just all sorts of weirdness. But it works. This thing actually works, and now we are finally getting numbers being displayed on the board that correspond to button presses. I mean, how cool is this? That's not good. Thankfully, there was just too many items in the hopper. It's absolutely fine. Panic over, because I can promise you there was panic. This might just be the most satisfying thing I've ever made. Just look, I'm changing things on a tiny panel. I've got a tiny panel in Minecraft. Right, let's quickly connect up all the other numbers. Oh, yeah. Oh, yeah, that's the good stuff. That right there, that is a stunner. But you see, there is a slight problem with it, which is when we hit any number on the number pad, it changes all of the numbers in our pin code. And that is not very secure. That's pretty pants, to be honest with you. So we need to create a system that will stagger them. Now, I'm really hoping that something like this should do the trick. I mean, it will be ridiculously simple if it does work. Okay, it will be so impressively simple, but we could be onto a winner here. Yeah, of course, it didn't work. Of course, it's not that simple. Right, back to the drawing board a little bit. Pain, frustration, you know the drill by now. But I'm hoping my days of pain should be over thanks to this piston feed tape. Okay, so that has just picked up that one and activated that one over there. Oh, and now it's broken. I did not expect to struggle with this bit, I must admit. I think my brain's a bit frazzled from constructing this monstrosity. But actually, it wasn't. You see, the first idea that I came up with, you know, the one that I said was ridiculously simple, turns out was actually the correct idea. I just executed it slightly incorrectly, but now that I have rewired it and done it properly, it's working perfectly, and it is ridiculously simple. I'm sorry I doubted you, brain. So with that circuit now in place, we should be able to independently change the numbers. So, for example, we press this one. Just that one changes. Then it should be the second one. Oh my goodness, this is exciting. This is very, very exciting indeed. And then it should loop back to the beginning again. It works! It works! This is cool. I keep doing it on the big one when really I should be doing it on the tiny one. I mean, how cool is this? Ah, warmth in my chest. Feeling warmth in my chest right now. Oh yeah. The finishing touches are going in now. And it just keeps getting cooler and cooler by the minute. But you may be wondering what this little bar of blocks is. Well, that is going to be the correct code indicator. Not only do I want our door to open, but I also want something to be signified on the actual number panel itself. And I think I have just about enough space to make something work here. Just about enough space. So currently our lever is powered, which means that the red blocks are up. But if I flick this lever, everything drops down and that bar goes to green. I mean, it doesn't have to be much more complicated than that, does it? There's just one final thing we have to do, arguably the most important thing that we have to do, and that is program in the correct combination. Now, I was going to do something stupid, like do it as 1, 2, 3, but I'm sure all of you would have called me an idiot for it, so instead I'm going to do it something equally as memorable but not as predictable, which is the number of days in a year, which everyone knows is 356. And with that, it's now ready to go. So here we have our little screen next to our incredibly secure door, and if I start smashing numbers into this thing, you can see that we need to get the correct number to actually get inside. If I put in, say for example, 467, everything stays red and our door stays completely closed. However, if I type in the correct combination, which is 356, so there is the 3, there is our 5, and then here is our 6, you can see that the green bar slides across, we get a nice little sound, and our door opens up, giving us access to all of our valuable items. Now, once we're done with this place, I've actually added a really handy little feature into our secure system, which allows us to reset the code so that nobody can see what it actually is. We don't have to worry about scrambling it ourselves. Everything is just wiped out, it's cleared off, and obviously our door closes back up. I mean, is this not one of the coolest things in the world? Like, this is seriously awesome. It's like the least vanilla Minecraft thing in the world, but I still really want it in vanilla Minecraft. I could play with this thing all day long. And I'm going to be totally honest with you, I really am quite proud of myself when it comes to the redstone behind this thing. I mean, it is a pure redstone logic mess, but like a beautiful mess. I mean that in a nice way. This thing is awesome. So we have it, ladies and gents. That is my little 1x1 security system, pin code, whatever you want to call it. I'm chuffed to bits with this thing. I hope you're chuffed to bits with it as well. And I'll catch you in the next video. See ya.